Okay. So let's continue on with problem 68 first. Slightly simpler Ferris wheel problem. These are the equations that we sort of derived in that initial video. And so let's plug in some numbers. They tell us that, we're going to talk about Matthew first and worry about the ball second. So forgot to mention that. So we're just talking about the Ferris wheel right now. Let's plug in some numbers. The Ferris wheel turns counterclockwise 1 revolution every 20 seconds. So t equals 20. That means our angular velocity is 360 divided by 20, or 18 degrees per second. And r is 71. So write in 71 here and here. So now we have expressions for x and y, but of course I'm assuming that our coordinate system places the origin at the center of the circle, center of the Ferris wheel. And here's Matt over here, Matthew at time 0. Okay. So we can find Matt's position in terms of x and y, but let's call this x prime and y prime, because this is not the coordinate system ultimately we want to use. Because we have the ball factor over here, this guy's going to throw a ball. We want to make the origin down at the bottom of the Ferris wheel. Okay. And they, in this case, they say that's okay because we're assuming that the bottom of the Ferris wheel is the same height as that height at which the ball is thrown. So making a little assumption there. How does that affect our values for Matt's position? Well, it's simple. It doesn't affect x. So we can say x equals x prime. But y is affected, but it's simply y prime plus r plus 71. Okay. So let's write out our parametric equations. X equals simply 71 times cosine of 18t. And again, we're just working in degrees. I'm kind of sloppy with the units, but that's okay, because the units are all going to work out fine. And y equals 71 plus y prime, which is 71 times sine wt, or excuse me, 18t. And that's not a w, that's omega, but again, I'm being sloppy. So 18t. And we can simplify that by just saying 71 times 1 plus sine of 18t. Oops. So those are our parametric equations for Matthew. And for the ball, that's easier. We've talked about projectiles already. But let me go ahead and start another video talking about the ball.